Okay, here we go. So votes, don't forget to get them in. It's close. It's close. I say it's close. It's within 10. I will post at 3 o'clock today if you guys are testing on Wednesday or not. Not Wednesday. One test, the combined.
Which one's the lead?
I think the combined. I think. Okay. 10-2. So confidence intervals. Please remember, regardless if we're testing chapter 10 by itself or we're putting 10 and 11 by itself, you will have a confidence interval open response question. And it will say construct and interpret. Okay? Regardless if we have one test or two tests, one of them will be a confidence interval question. Okay? I don't know if it will be one sample, and I don't know if it will be two sample, and I don't know if it will be proportions or if it will be means. But you will have a confidence interval open response question that will say construct and interpret. Y'all okay? Please don't get bad scores on it. I'm telling you what the question is. Okay? I'm telling you what the question is. And you guys that are glued to your computers right now are probably missing out that that's the question that's on the test. And sometimes there's a direct correlation to being glued to your computer and not paying attention and taking notes. Y'all are full of choices. Y'all are seniors most of the time or juniors. You're getting really close to college. They're not going to care if you take notes. So I'm trying to teach you that I don't care if you take notes. And some of you don't have to take notes. But there's a pretty good correlation to those that aren't taking notes and what the score is in the class. Pretty good. Without an experiment. I haven't done an experiment. It's an observational study, right? 10.2. 10.2. Most of this you know. You still got you still got T's. You still got T's. We're still doing X bars, and we're still calculating a mean. In this particular one, I'm looking for a difference. And so what we got here, guys, is we're going to have two different samples. Okay, two samples. And I don't necessarily care what the average is. That's why we're doing one sample, girls. Okay? I want to care what the difference between the averages is. And if it's positive, then this difference is higher. If it's negative, this difference higher. And if zero's in it, then there's no difference between the two, right? Just like we did in 8.3, except that was proportions. So all the stuff you already know, we're throwing in together. And so we'll go through this fairly quickly, but I do want to make sure that I don't skip something that will miss you guys some points, right? I jump right into the conditions, right? I jump right into the conditions, which is nice because you guys already know the conditions. One of them is random, except it won't be random this time because we need two independent random samples, right? We need two independent random samples because we're dealing with two different populations or two different samples. So if we need two independent random samples, what do we need? What's another one we need? We got random sampling, we got large counts, and we got the 10%, right? In this particular one, and again, don't get into the habit of just saying 10%, right? 10%, writing that on your paper will not do it. You need your sample to be less than 10% of the population, Okay, that has to be stated. You don't have to put it in context, but you got to put that. 10% check doesn't do it. Okay, and this one is both, right? Both need to be less than 10% of the population. Both need to be less than 10% of the population. That proves independence. Just so you guys, I mean, I don't know if I for sure mentioned that per se, but that proves independence. And then Olivia said we needed the large counts, but they both need to be large counts. And so hopefully N1 and N2 are bigger than 30. That's what we would like, right? When we're dealing with means, we're looking at the 30, not the 10. 10 is for N times P and N times P hats and all those other things. N times P hat sub C's. Those are all 10s. This one's 30. If it's not 30, hopefully the population is normal, which hardly ever happens. That one hardly ever happens. Or you're going to have to graph it. And I don't mean it, them, right? Now, if one of them's over 30 and the other one's not, you'll have to graph just that one. On the test, you will have to graph. I don't know if it's one sample, and I don't know if it's two samples. But it will not fit the 30, and you do not know what the population looks like, so you will have to graph it. What do we know about the graph? We don't want it to be what? Strong, skewed, or have outliers, okay? As long as those two things are okay, we'll proceed on. It doesn't have to be a beautiful graph. Prove to me, prove to the grader that you did it. So sketch, sketch. Everybody good, right? 4 points, 3 points. I don't know, 3 or 4 points. Just by checking the conditions that you guys already know. But there's a lot of -3s on the test because we're not checking conditions. Even though I tell you how nice the weather is. That was the hint. Conditions. Y'all good with those 3? Yes? Anything about it? Yes, sir. Yes. You don't have to. You can. You don't have to. All you got to do is N is greater than 30. N, I like to, N equals whatever, 47, which is greater than 30. That's all you got to do. Okay. You can say, which shows me approximately normal. It does fit the central limit theorem. That's all okay, good, well. Good question. Y'all okay with all that stuff? I'm just happy if you can get that part of it. Random, 10, what the heck was, oh, I skipped a button. That's my example. A college student wants to compare the cost of 1-bedroom and 2-bedroom apartments. She collects the following data in monthly rents for dollars in 10 random sample of 10 apartments. Random samples. 1 bedroom, 2 bedrooms. Let mu sub 1 be the true mean monthly cost. Mean. I told you guys, you should not get confused as this means or proportions because they'll mention it. It's either numerical data or it's categorical data. It's either proportions or it's means. Mu sub 2 is a true mean of a 2-bedroom home. They want me to check if the conditions are met. So we have 2 independent random samples. That's all you got to say. 2 independent random samples. 2 independent random samples, 1 bedroom and 2 bedroom. 10 1-bedrooms, 10 2-bedrooms. The more you can put, the better you're going to put, but you don't want to write a novel. Any questions about that, right? Yep. Most of you guys have been doing a really good job, those that write it, on this. I'm not seeing a whole lot of SRS check. The worst thing is just forgetting to put it. Okay? Clicky, click, click. Good. I don't know, but I'm going to assume that 10 is less than 10% of all. So SRS of 10 1-bedroom and 10 2-bedroom. That's good enough. That's beautiful. That's good enough, right? 10 is less than 10% of all 1-bedroom 10 is less than 10% of all 2-bedroom. Beautiful. Beautiful. Okay, I need to see less than 10% in that of all, because we got to refer it to the population. I've seen some weak stuff on the 10%, not a lot, but some weak stuff. 10% check, that didn't do it. And then we had to graph both of those. We had to graph both of those. I would put this in L1 and put that in L2 and use my box plots. They used dot plots. They don't care. Dot plots are less. Boom. Stat edit, right? L1, L2. This is not the data. I just got this in. I think this is pre-cal data. But put it in L1 and put it in L2. Y equals, I check to make sure I don't have anything in there, and then second Y equals, and I'll graph L1 here and L2 here. Desmos will do this also, right? You guys are getting comfortable with Desmos. Turn it on, make sure you do the modified, make sure it's L1. Go to plot 2, turn it on, modified, L2, hit graph. You're probably not going to see it. Oh, I did because I already hit it. You're probably going to see something like this. You see a little bit of it. Always just hit zoom 9. And then you'll see both of them. Put that on your paper. And it's just a sketch, right? That one's really pretty because it was 1, 2, 3, 4, 5, 6, 7, 8, 9. Center that one off a little bit, make those a little bit shorter. You don't have to, if you get really concerned about it, like you're not, just hit trace. Hit trace, and it will tell you what those numbers are. That's 6.5. So if you want to label that, that's fine, but they don't require it. Y'all okay about what you're needed or what's expected from you guys? You will have to do that on the test. I don't know if it's 1 sample. I don't know if it's 2 samples. Yay? What? Second Y equals, that's right. Enter, whatever. Go down, and it's second 2. There's L1, L2, L3, L4, L5, L6. Good question. Yes, sir.
So when you graph it on that part, you don't have to write numbers on it.
You don't have to, just sketch it. Yeah, just sketch it. Officially, box plots are not great because you really can't tell shape from box plots. Officially, according to AP stats, you can't. But they're okay with doing box plots for this because you're looking for something really weird, outliers, and those show outliers really well. Great question. Anything else about that? You guys are awesome. Beautiful, beautiful, beautiful. Okay. Hey, on the AP test, guys, that's its own EP or I. That's its own EP or I. E gives you a whole point. P gives you a half a point. And then there's a multiplier. We'll talk about more about that as we get closer to the exam. It's not just 1 point. It's 1 times 1.8. It's almost like 2 points. Okay? Click. The formula for 2 sample. The formula for 2 sample, you know this already. For 1 sample, this is statistic. I don't know how well of a job I did on this. I probably didn't do very well. Statistic is X bar, critical value is T, and the standard deviation over the square root of N. That's for 1 sample. That's for 1 sample. This is called the standard error. You had a multiple choice question on the standard error. So that's what this part is. I did not do a very good job of explaining to you guys that that's the standard error for means. That's the standard error for means. It's on your formula sheet. It's on your formula sheet. It's on that second page. You'll see the proportions, and then you'll see the means. And you'll either see S over the square root of n or you'll see sigma over the square root of n, but we don't know sigma, so we're going to use the S one. Okay? For two samples, today's work, we're going to have statistic is going to be x bar 1 minus x bar 2. Okay? Plus or minus, and it's still going to be a t. It's t because we're estimating a whole lot of extra stuff. We don't know population information. And then the standard error, remember, right? If you have two, you don't add standard deviations. You have to add variances. So I have to square that, which makes the radical go away. And then I have to square the second one, which makes the radical go away. And then I take the square root of the whole thing. And again, that's on your formula sheet. You don't have to write it. You will see it on multiple choice. They'll plug stuff in there. Most of the time, that's the number that's changed. So that's finding that critical value, which you guys should already know how to do. Yay, good. That part right here is on your formula sheet. This is on your formula sheet if it's one sample or if it's two samples. Okay? I don't think we'll ever have to write it. Oh, here it is. DF, huh? To calculate the degrees of freedom is a really difficult formula. It's not on your formula sheet. I'm not lying this time. That's the formula to calculate the degrees of freedom. I know. How many times do you think you're going to use that formula? 0. 0. Because your calculator will give you the degrees of freedom for a 2 sample. It did not give you the degrees of freedom for 1 sample. But luckily, degrees of freedom for 1 sample is simply n minus 1, so we could do that one pretty easily. This one is horrendous. It's horrendous. And your calculator will give it to you. I'll show you in just a second. I want you to know where your calculator is getting that number from. Okay? It's just a crazy formula that we will never, ever have to use. It has to do with the standard deviation of the first one and the sample size and the standard deviation of that one. But then I'm going to square it again. So I got the variances, and I'm adding the variances, but then I'm going to square it. And then we got 1 over n minus 1. And then I got that squared, a whole lot of stuff going on. You won't ever use it. You won't ever use it because it's done electronically. I just want you guys to see it. Okay with all that? So the calculator will tell you what the degrees of freedom is. If your calculator doesn't tell you, and you need to state what they are, you're going to use the smaller of the n minus the 1s. Use the smaller of the n minus 1s. If they're both 30, you're going to use 29. If one of them's 61 and one of them's 82, you're going to use 61 minus 1, which is 60. Use the smaller of the n minus 1s if you have to. Okay, I think you may have to on a homework question. I think is the only time I've ever seen it. Okay, use what your calculator lets you do. Desmos will also give you the DF. Desmos will also give you the DF. Okay, everybody okay with the DF on this? It's different than 1 sample, and it's bad, but your calculator just gives it to you. And it's always a decimal, as you can only imagine how that comes up to be a decimal. It's never, I don't think it's ever an integer. Okay. I've got Wade Tract Preserve in Georgia. It's an old growth forest of longleaf pines that has survived a relatively undisturbed state for hundreds of years. One question of interest for the foresters: how do the size of the longleaf pines in the northern and southern has compared? To find out, researchers took a random sample of 30 trees. Thank you. From each half and measured the diameter at breast height, DBH, in centimeters. Here's the summary statistics. So I can see from the northern half, we have 30 trees, and there's their mean, and there's their standard deviation. And here's the southern half, and here's their mean, and here's their, oh, that's their number, and here's their mean, and here's their standard deviation. And they actually put me a graph of those two. I don't know if they had to, but they did. Ooh, here we go. We're going to dig up the past. Right? Oh, based on the graph and the numerical summary, write a few sentences comparing the distributions. Better compare what? Shape, spread. Oh, cuss, I can't remember. Center, unusual, shape, spread, BS. Be specific. Yes? Why do you think I say all cuss all year long? Huh? Because I can. I mean, I can't cuss, but I can say cuss. You can't tell me values. Don't say the center of the north is 23.7 and the center of the south is 34, because that does not compare. That just tells me what they are. The center of the north is less than the center of the south. The spread of the north is more than the spread of the south. Shape, I got center, spread, shape. The northern data is skewed to the right. The southern data is skewed to the left. Neither have outliers. In context, I did all that. Yes, no, maybe? 6 points on the test. I don't know if that's going to be asked or not. It will be asked at some point. I will bet anything. Well, I won't bet anything. I'll bet a lot that it will be on your AP test. They have asked you to compare the last 4 years. The last 4 years, 5 years is compare the distributions. Higher, lower, about the same. Yay? Ooh, I know, that's been a long time ago. Click, shape, outliers, center, variability. Construct and interpret. That's going to be a question on this test. Construct and interpret. Construct and interpret. And 90% confidence intervals for the difference in the means of longleaf pines in the northern and southern halves. SRS of 30 northern, southern. Good enough. If you want to put greater than or equal to 30, whatever you want to do, large counts. 30 and 30 are less than 10% of all northern and southern pine trees. That's good enough. Don't write a novel. Check it. SRS. Oh, man, I didn't see how I did that. I kind of snuck that in on both. 30 is greater than 30, equal to, and 30 is greater than or equal to 30. Large counts. Don't write a novel, but don't do 30. Any questions about the conditions, right? 3 points, 4 points, 5 points, I don't know. I'm probably going to give you more than 4 points because you're going to have 2 graphs. Maybe 1 graph, I don't know. It depends on if it's 1 sample or 2 sample. I really don't know. And if you split them up, I don't know. One of them's going to be 1 sample, and one of them will probably be 2 sample, and one of them will be means, and one of them will be proportions if you split them up. If you combine them, one of them is going to be a confidence interval, and one of them is going to be a hypothesis test. One of them is going to be 1 sample, and one of them is going to be 2 sample. One of them might be means, and one of them might be proportions. I don't know all that. That's kind of fair game. But those are the two questions. And then there'll be something else extra. What's the difference between this? Or I don't know, who knows what, right? Everybody okay with that? Good? So I got the conditions. I need the method. To SAMP mean, we get in the habit of saying prop all the time because we said prop for 2 chapters. Now it's not prop, it's means. So don't say prop. Don't say prop. If you accidentally say prop, put an X to it. Anything with an X to it, we can't grade. To mean T, and then don't say test. This is not a test, it's an interval. Int. So be careful, right? The methods are starting to pile up on us, guys. We had 2 methods in chapter 8. We had 2 methods in chapter 9. Now we got 2 methods in chapter 10. We'll get 2 more in chapter 11, and I think we'll get 3 or 4 more in chapter 12. So the methods start getting quite a bit more. And so that's where it's starting to be real important that you make sure you put down the method by name or formula. And I recommend name. Everybody okay about that? And I don't care where you put it. I don't care where you put it. This is one of those guys when the students that have done the big plus sign, there's very few of those that have minus a whole lot of points. Because they remember they got to have something in each of those quadrants. And that helps you. The ones that are writing the big old plus sign and putting something in each quadrant are typically doing really well. Not to say that if you don't do that, they're doing well too. But some are just saying, I'm throwing this up there and putting this up there. That's where we're missing some points because you're forgetting some things. Method. Then what you're going to do is you're going to tell me what X bar 1 is. You're going to tell me what X bar 2 is. I might use N's and S's, northern and southern. And then you got to tell me standard deviation of N and the standard deviation of the south. And then you got to tell me N of the north and N of the south. Then you got to tell me the DF. But your calculator is going to tell you all this stuff. So let me go to my calculator of what should be expected from you guys. Not a lot. Stat. Tests. It's not a test. 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 It's not a Z interval. It's never a Z interval. It's not the T. That's for 1 sample. There's a 2 samp Z. That's not it. It's a 2 samp T. And you either have the data or you have the statistics. In this particular question, we had the statistics. And so you'll put X bar 1 here and you'll put X bar 2 here. And if somebody wants to put the northern first and the southern second, and that's okay. If you want to put the southern second and the northern first, that's okay. I think I said that all backwards, but now they did say northern and southern, so I would probably put the northern first. But they won't care as long as you explain it. Enter all that information. Confidence level. Never in the pool, it's going to ask you pooled. I don't know if you guys in the back can see that. It says pooled. Just always say no on pooled. Just say no on pooled. Many times in your life you need to say no. This is one time that you better say no. Haha. Yay. Calculate. Boom. There's the interval. There's DF. There's X bar 1, there's X bar 2, there's standard deviation, N1, N2. Just put all the information. Put all that and that's your calculations. That's all you need for calculations. They actually put the method and the calculations together. They combine all that stuff. I make this 3 or 4 points and I make the method 2 points. Just the method by itself is 2 points. There's somebody turned in their test last chapter and put down 1 or 2 samp prop Z int. And they got 2 points. That's all they got. They got 2. Okay? Questions about the calculations? Conclusion, we are 90% confident, or 95 or whatever this was, right? That the interval from here to here captures the true mean difference. between the northern halves and the southern halves, or if you did southern half minus northern half, or however you did it, just make sure you're consistent. Sorry, O. Questions? Yay? Easy? There's a lot of stuff to write, guys. It's a lot of points. A lot of points. 14 points, 13 points, 15 points. I don't know. It's what they are. Like I said, some of you guys are, that's why we're getting the 15s out of 15s and we're getting the zeros out of 15s. 13 out of 15s because we're forgetting the conditions. We're forgetting to put a p hat here or there, or x bar. 14 out of 15. Good. That's not bad. If you forget one thing, it's okay. It's not going to kill you. You forget all of it, it's bad, right? Bad. I was in a bad mood grading those tests. I don't like giving bad grades, especially when you know the question. And it only takes a couple of you guys. Any questions about that? Y'all good? Easy. Should be, I hope. I'm hoping this is starting to get boring for you guys. I'm hoping. I mean, I don't really want it to be, but if it's getting boring for you, you got it. Oh, this doesn't change anything. This does. They do state, plan, calculate, or do conclude. That's what they do. I like MC cubed. MC cubed. Method, conditions, calculations, conclusions. I will for sure need that. The difference. The true difference in the means. I think I said that backwards. I think I said mean difference. That matters. You want to make sure you say the difference in the means. Yeah, did I say true mean difference? I think I did. Yep, my fault. You'll find out in a second where that was a mistake. That's the only thing I really got to teach you on this chapter or this section. Yeah, I think I said mean difference. That's wrong. Listen, let me explain to you why, especially you English people probably catch this because you understand. Mean difference, that's the average of the difference. We didn't do the average of the difference. We did the difference of the averages. So I want the difference of the means. Yay? Okay, click, click, click. There's where it's always no pooled. All right, questions? Most of this stuff, guys, you probably had a lot of blank stuff on your notes, and I get it. You guys got all this stuff, hopefully, whatever you need. This is new right here. This is new. So let's talk about this for just a second. A researcher studied a random sample of identical twins at birth. They were separated at birth. They were separated at birth. In each case, one twin was adopted by a high-income family, the other twin by a low-income family. After they were adults, they gave them IQ tests. They gave them IQ tests and wanted to see if there was a difference between the two. Well, in this particular one, we have an issue because we have twins separated at birth. Here's twin A's high income IQ. Here's the low income IQ. In this particular instance, ladies and gentlemen, I'm not as concerned with what this average is and what this average is. I want to figure out the difference between each one of them. Y'all with me on that? And then I'm going to figure out what that average is. That's not the same thing. I keep trying to say it's not, that's different. But then the difference is good. It's not the same. It's not the same as figuring out what this average is and this average is. That's for two independent random samples. And that's why we say the difference of the means. In this particular one, it's not really independent. Twin A and twin B have all the same genetics. They grew up differently. They're not independent. Fair enough with all that? So I want these differences and calculate that. That's introducing it to you. Let's kind of go on a little bit more. Here we go. Ignores the fact that they're paired data. Paired data. Paired data can happen one of two ways. One of two ways. It typically happens when you have I didn't put it up here, but it's the same, you have basically a before and an after. Basically, you're pairing it to yourself. A before and after. Two values from the same variable, right? It's pairing it to itself. Or they specifically pair similar individuals some way, some form, some fashion. And typically it's said so in the problem. This is one of the hardest things to catch. It's very obvious if it's one sample proportions, if it's two sample proportions, if it's one sample means. Those are obvious. It's sometimes not as obvious if it's two sample means or matched pairs. I think that is the hardest thing to distinguish between which one that is. Matched pairs. To make it nice for you guys, if you mess up and it's matched pairs and you don't match it, it doesn't kill you. Because you're still going to do all the conditions, all the calculations, and all the conclusions. So they're not going to ding you the entire thing for doing the wrong thing. Fair enough with that? So, not going to get 100. You're probably not going to get a 5, but you're going to do enough to be able to pass. Or if it's not matched pairs and you pair it, same thing. Okay, so now, on my test, I think it's pretty obvious if it's matched pairs or not. I think it's obvious. But I think that is the hardest out of all of the others. Y'all okay with the definition of paired data? Click. When we do that, that's when we're talking about the mean difference. And that's why I told you guys incorrectly when I said mean difference. Okay? When you see mean difference, that's paired data. There's only one mean. It's the differences of all those values. It's one mean. Differences mean. It's the mean of the differences. I guess this is plural, right? The mean of the differences. Or the other one is the difference of the means. You have one subtraction, two means. This one, you have a bunch of subtractions, one mean. Everybody good? Pencils, 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 papers, good, typing, whatever we need. Yay? Happy, happy? I really do love you guys. Click, click. After you subtract them, it's one sample. After you subtract them, it's one sample. So that's what we learned Wednesday. After you subtract them, you have one set of data, it's one sample. So the DF would be n minus 1. DF is n minus 1. You only have one X bar. You only have one T score. You only have one standard deviation, and then you only have one value of n. Good enough with all that, right? It's just one sample after you subtract them. So you'd put all these bad boys into your L1, and you'd have to graph L1. And you got to find the mean of L1, and you got to find the standard deviation of L1, and you got to find N of L1, and you got to find DF of L1. Then you got to write your conclusion from L1. And you got to do your conditions from L1. Let me talk about the conditions just a little bit because we're going to throw a little bit of wrinkle into those. They're still the same three. Still the same three. This is where I said this already, but I want to make sure you know, right? Two values from the same variable, typically a before and after. A before and after. I'm going to test your typing speed, and then I'm going to give you a typing program, and I'm going to test your typing speed. I would bet you the average is going to go up, but I want to see how much it goes up on the average per individual, not necessarily the entire group. Okay, that's why it becomes one sample. Or you're going to pair them. Okay, two ways: a before and after, two from the same, or you're going to pair them some way. The twins, you planted two trees at the exact same time. This one gets fertilizer A and this one gets fertilizer B. Whatever. Okay? Whoop! Whoop! Bam! That's better. I'm recording this one. Forgot to record yesterday. You guys are getting the recording. So don't ask stupid questions. Don't flip stuff. How do I do this? I don't know how I did that. Click. Conditions are a little different. Random set of paired data. Random set of paired data. So go ahead, when you start realizing, hey, I'm going to pair this stuff up, or I'm supposed to pair this stuff up, just start throwing that word pair in just about everything. The set of differences is less than 10% of all. The set of differences is less than 10% of all. You might even note they'll do that sub D a lot. N sub D. Differences. If you really want to be technical, you can put DIFF. They don't care if you put anything. You can write it in words, show it in symbols, whatever you want to do. And then the number of differences is greater than 30. The graph of the differences shows no outliers. Sure.
I'll be back later.
You're welcome.
The best.
No, these guys are the best. Oh, oh, oh. Z. Almost as S. A. T. U. Woo! I went to Tech. That's what we did. A. T. We weren't real smart. That's about how far we could get you. Woo! That was pretty cool. Yay, yay, yay. You guys are awesome. Y'all writing too much, but that's okay. Can't say that about people who are doing good. You're writing too much. Seen my friend lately?
Huh?
Seen my friend lately? Have you seen my friend lately?
Oh,
You doing okay or? Yesterday for lunch, they had some extra stuff, and I had cinnamon roll. Boy, just I was all over the place. Quit giving Mayor sugar. I don't need sugar. I don't need caffeine. I sure don't need drugs. High on life. Click. You good? They'll show the formula like this. You won't do it like this unless you really, really want to, right? It's X bar. There's the T, there's the S, and there's the N. They just put that little sub D's. Just if you want to do that, it's good. If you don't want to do that, it's not bad. It just emphasizes of what you're doing, right? X bar sub D. Put it or don't put it. They don't care. The more you can talk about that you're doing the differences, the more we know you're doing the differences. And if you're doing it right, the more validity you have. And if you're doing it wrong, doesn't matter because you started off wrong, but at least you're consistent. Good? N minus 1 for the degrees of freedom. N minus 1 for the degrees of freedom. Okay? Again, that's the easy one. It's just one sample. It's just exactly what we did Wednesday. The hardest thing is deciding if it's matched pairs or not. That is absolutely the hardest thing, to decide if it's matched pairs or not. You'll have some homework questions tonight to help you decide on is it matched pairs or not. You put all those differences in L1, right? We'll have to a random sample of 12 pairs of identical twins. 12 is less than 10% of all pairs. There's a graph of the paired. Again, they use dot plots a lot. Box plots. Here's X bar sub D. There's the standard deviation sub D. There's N sub D. There's DF. There's the T critical value. I don't ever show all that stuff. I'll show everything else. I don't show this. I don't write that down. One, it takes a while to find it. And two, when I do find it, it may not be the same one my calculator used, and it just doesn't match up. So don't lie. And I don't show all this anymore. I just put that right there down. This is what they're going to look for. Mean difference. Again, where I messed up earlier. I messed up earlier on that. That's the average of the differences. And if you want to say it like that, that's okay. Where 3.36 to 8.3 captures the true average of the differences. The population. Just make sure we use that word, right? That true word. That's the big one. That's the real big one. Clicky, click, click. I hope you can determine if the conditions are met. I hope you can construct and interpret. I hope you can analyze the distribution of the differences in paired data, and I hope you can construct and interpret the differences of paired data. Let me go here. Let me hit this button.